When you're learning to code, you pick up the basic rules pretty quick. But then there are these other rules, these kind of hidden rules that explain why things really work the way they do. Today, we're going to uncover one of Python's most important and, honestly, most surprising hidden rules. So let's just dive right in. Okay, imagine this. You write a word down on a piece of paper, and then you spot a typo. But what if you couldn't erase just that one letter? What if you had to throw out the whole piece of paper and start all over again? Sounds kind of weird, right? Well, that is exactly how the most common data type in all of Python actually works. Just take a look at this. We make a string, Python, all lowercase, simple enough. Then we try to do something that seems totally logical. We just want to change that first letter, the one at index 0, to a capital P. But nope. Instead of working, Python just throws up its hands and gives us a type error. It's basically yelling at us saying, hey, you can't do that.
So what's going on? Is this a bug? Not at all. This is actually a core feature of the language, and it's there for a very good reason. To figure out why Python stops us, we've got to dig a little deeper. So let's start our investigation.
Okay, before we can solve this mystery, we need to get crystal clear on our main piece of evidence. What even is a string, really? At its heart, a string is just a sequence of characters, and the order matters. Think of it like a train, where each character is in its own numbered car. We call that number an index. And, as you probably know, in the world of programming, we almost always start counting from 0. So, in our string hi there, the H is in car 0, the I is in car 1, and it just keeps going.
And of course, every string has a length. That's just the total number of characters it has. Python gives us this super handy function, len, to figure this out in a heartbeat. For hi there, that's 9 characters, so len gives us back 9. Pretty straightforward. All right, we've got our definitions down. Now it's time for the big reveal. This is the one concept, the one secret that makes everything else we've seen just click.
The secret is one single word, immutable. It sounds a little fancy, but all it really means is something that once it's been created can never, ever be changed. Period.
So why on earth would Python's designers do this? Well, it's actually super clever, and it boils down to 2 huge reasons: efficiency and safety. For efficiency, think about it. If you have the word hello 1,000 times in your code, Python doesn't need to store 1,000 copies. It can just store it once and have all those variables point to that one single copy. And that leads directly to safety. Because that string is shared, if you could change it in one place, you would accidentally change it everywhere else. That would be a complete nightmare to debug. Immutability totally prevents that chaos. So here it is, the best way to think about this from now on. A Python string isn't like text on a whiteboard that you can just erase and edit. No, it's like a message that's been carved into a block of stone. You can read it, you can look at it, but you absolutely cannot take a chisel and change a single letter. And that is exactly why our first piece of code failed. When we tried to do s sub 0 equal p, we were literally trying to take a chisel to that stone carving of Python. And Python's job is to protect the integrity of that stone, so it just stopped us in our tracks with that type error.
Okay, I can hear you thinking, but wait a minute, I change strings all the time in my code. And you know what? You're right. It definitely looks like you do. But what's really happening behind the scenes is this really clever illusion.
Let's break down what's really going on. When you write code like s equals Python, you aren't editing the original Python string at all. What actually happens is Python goes off and carves a brand new stone tablet, this one with Python on it. Then it just tells your variable s to stop looking at the old stone and to point to this new one instead. The original Python stone, it's still there, completely unchanged.
So this is the absolute crucial takeaway. The strings themselves never, ever change. The only thing that changes is the reference, that little pointer from your variable name to the string that lives in your computer's memory. That is the heart of the illusion. So if our strings are carved in stone and we can't change them, how are we supposed to actually work with them? How do we read what's on the stone tablet?
Well, your main tool for the job is going to be the subscript operator. Yep, those square brackets. You just give it the name of your string, and then inside the brackets, you pop in the index of the character you want to look at. This lets you inspect any character you want without ever trying to change it.
And here we can see it in action. So name 0 gets us the first character, A, and name 3 gets us the fourth one, N. Python also has this cool little trick where you can use negative numbers to count from the end of the string. So name -1 is a super fast way to grab the last character, and name -2 gets you the second to last.
Just be careful. If you ask for an index that doesn't exist, like trying to get the 12th character in a string that's only 12 characters long, which would be index 11 since we started 0, Python will throw an index error.
So we've cracked the case. We know that strings are immutable, they're carved in stone for really smart reasons. So here's a question for you. Now that you know this, how does it change the way you might think about building your programs? When you're handling a lot of text, you now know that every single change you make is actually creating a whole new string in memory. It's one of those fundamental rules that once you really get it, you start seeing its effects everywhere you look in Python.